This conference will now be recorded.
We can go with some background introduction about yourself, and I would like to give some intro about myself upon that, and we can start the demo session. Okay, so feel free to talk to me, or you can message in the chat box, whichever it is comfortable for you. So just give me some basic details like your name and what is the motivation to take the DFT course or joining into the this field of VLSI. If you're already a working professional, you can let me know what is that your motive, or is it something like you are a college graduate and looking for some career opportunity in VLSI, or what type of field you are currently into. Just give me some basic introduction. You can type in the chat window, or you can speak to me. Anything is okay for me. Okay. Yeah, go ahead.
Hello sir, my name is Sandeep Reddy. I am from Tirupati, Andhra Pradesh.
Okay.
Now presently I am working in Tirupati, sir. It's an electronics manufacturing company. So in that company, I working as a debug engineer, sir. So why I choose the DFT means in my field, I mean in electronics manufacturing industry, we manufacturing a mobile phone, sir, Jio 4G mobile. So in that I am working as a debug engineer, like troubleshooting the PCBA. So we found some ASIC issues, like circuit short, open. So we found different problems.
On the board or in the IC?
Motherboard.
On the motherboard.
Motherboard. So and after we confirming the IC also, like a vendor issue, which is a IC vendor issue. Whether
so
it
you're
is,
more
whether
motivated
we,
to understand how do you test the chip rather than simply a board.
yeah, sir. Yes, sir.
Okay. Yeah, good to know that.
Yes. Thank you.
Yeah. How about others? Indira, Karthik, Kasuri, Anila, Kumar, Basavaraj, Naveen, Onkar, Rahul, and then Sinbagavalli. You can at least type in the chat box. Just let me know some basic details about yourself to understand more.
Hello, sir. Hello, sir.
Yeah, tell me. Go on.
Myself, I am Anila, sir, and I am a fresher. I just completed my BTech in 2022, passed out.
Okay.
As a fresher, I am very interested in VLSI, and the DFT domain is very easy and it is non-coding. That's why I need to choose this domain, sir.
I agree with your statement that it is not coding, but I do not agree with the other statement that it is easy. Okay.
Okay,
so
sir, not a problem. In my opinion, that coding is not there, then that is very easy to me.
Okay. Good to know that. Yeah. Okay.
Thank you, sir.
Yeah. Can we hear from others, or you can chat? You can type in the chat box. Just 2-3 lines should be 2-3 lines should be sufficient. I don't see any responses. Okay, I got one response. You're working in DFT domain. Okay, you have worked in tap link. Okay. What does I didn't get the complete statement. To know whether would like to work on DFT topics like TPG. Okay, good to know that, Onkar. I can understand that. I mean, by looking into the terminology, I can understand where you're working and what you're working on. That's good to know. We'll for sure get to know a lot of other things other than tap link, its validation and all. Okay. So okay, another message I got, you're working already and you want to interested to learn. Okay, good. So I got two responses from Omkar and Baswaraj. See, if you can while sending the message, there'll be an option called send to. If you're willing, you can keep it everyone, or you can keep it to presenter or to me, organizer, and you can type like.
Hello.
Yes, Naveen.
Sir, I'm calling from Andhra Pradesh. I'm Naveen. Actually, I changed my domain. Already I'm working 8 years experience in CAD designing section, actually garment sector.
Okay.
But I am passed out 2013.
Okay.
It is very
What is,
any helpful
yeah.
for now I can choose this option.
I know it's quite long, almost equal to 10 years, 9+ years, right?
Yes.
It depends on companies actually, Naveen. If you're strong
Okay.
enough to prove that, okay, you're good at basics and other things, people may consider you. There is nothing like they will not consider, they will for sure consider. Okay. Yeah. So see, it's irrespective to the gap what you have. You may be, relieved, or you have been completed your graduation in 2009 or 10 or 13, whatever it is. So if you are able to justify, at least telling that, okay, I have into some other sector, I moved with redundancies. Okay. And you are good enough to prove that you'll be able to handle the things in the practical projects and all, people will for sure consider, because I have seen n number of people.
That 11 module, what are you doing without clubbing arranging or plan?
Background noise. If you're not talking, please keep in mute.
Okay, right.
Yeah. So as I said, like opportunities will be there based on your skills. I have seen many people who are working as lecturers and professors in different colleges and universities, and they would like to switch their career, and they also got placed in different companies and allocated to different projects. So as I'm telling you, right, you should prove that you'll be able to handle the project technically and practically. If you are up to that mark on these two things, yes, for sure you'll be able to do it. You'll be able to crack it. Chandra, this is not session for FPGA. This is for DFT, as you see on the screen. Designed for testability and testing, DFT course demo session on that. And Kumar, you're also working professional in software device drivers. Okay, that's good to know. And you were like interested to move to DFT. Yes. Okay. Let's jump into the session. Let me give some small intro. So I am Vamsi, and I'm the DFT trainer over here from past couple of years. So far, I've handled like 8 to 9 batches in VLSIGuru, and I have close to 10+ years experience in DFT alone. Before that, I worked in as an analog designer also. So I'll be covering wide range of topics in DFT, straight away starting from the architecture implementation, and then finally the validation and the support to the tester. So multiple components we have in DFT which are segregated. So we will try to see what is suitable, what is best for you guys, which we are completely following from previous batches and all. So initially there'll be some ramp up and brush up sessions, what the VLSIGuru will be providing based on the digital topics, Verilog and other stuff. So basic sessions, what we call, and after that the main session, the main course of DFT will be taken by me. Okay. So let me jump into the session and make you understand a little bit about DFT and how it is different from other domains in VLSI. So today's agenda, what I have is like, what is meant by DFT? What's the course outline? What are the fundamentals you need to start up the VLSI course? What are the different tools used in DFT? And what kind of projects and lab sessions we are going to provide? And of course, the materials also, how do we provide? We are going to discuss that. and there'll be some small slide about like placement opportunities and all. Okay, these are the course, the overall agenda of listed points which I would like to cover today. So who can attend the course? That's a very important point. Most of you may have a question whether you are eligible to take up this course or not. Right. So the first and foremost important for anyone to start any course is like whether I'll be eligible to attend this course, whether it really suits me or not, is the primary question you need to have. So a couple of points I made here. So a student who are in final semester or a college graduate who is from relevant engineering branches, professors or lecturers who want to switch their career also into real-time industry experience. Even the working professionals from similar or from different other domains also can attend this course. Who really want to boost their career into this DFT stream, they can actually attend this course. So I hope like every one of you will be fitting in one of these options or one of these statements which I made. If you're not, you can actually let me know from which type of sector you belong to. I can clarify that. So it's a 16-week of duration course, both theoretical plus practical. It can go beyond that also based on the interactions we are having. See, one batch I was able to do within 16 weeks. One other batch, it took almost like 18 to 20 weeks. One other batch even took 21 to 22 weeks. So it all depends on the interactions, what we are having, the doubts, clarifications, the amount of time we are spending on the topic. So of course, like it all comes, it's not straight away that I will be explaining some standard set of protocols and some other information, but it also depends on the interaction between you and me, like whether you're able to understand the topics in a simpler way, or if you're not able to get it, I have to route it through some other examples and explanations, illustrations and all. So based on that, the duration of the course will vary, but ideally the default duration is 16 weeks, what we have planned, which includes both theory and lab sessions. So theory classes will be on only weekends. Practicals can be on both can be performed on both weekdays and weekends. So I would be linking the theory and practice together. So we will take topic 1, complete the theory, go to the practicals, and then go to topic 2, complete the theory, then practicals, go to the topic 3, and so on. So each module, what we call here, we stress on the theory part first, and then we jump into the practical to see and understand the design and the challenges in it, and the topics what you need to learn in it, and then we'll go to the next topic. So it will, in a way, it would actually improvise your personal skills and analyzing skills the moment you interact more in practical sessions. So what skills are required to start the DFT course? The most common frequent asked question to me by many of the people: what are the basic skills I require to start up this course? So what things I need to learn before I start? So we have a couple of points here again, like you need to understand what is meant by VLSI design flow, and you need to understand what is digital design and electronics, and you need to understand you need to understand the Verilog coding structure. You don't need to design the code, but at least you need to, if you open the code, you need to understand the syntax and format of it, what is developed or what is existing. That should be much more sufficient for us. And we have some basic EDA tools, electronic design automation tools, which are widely used. So DFT is a work like where you implement some design and you make sure the design is implemented in the chip, you validate it and then give it to the testing team. So whatever the design you would like to add are all predefined and are standard set of circuits what we have in these tools. So the tools will have some standard set of designs. We are here to just pick up the standard set of designs which we require as per the requirement, and we would like to implement it and see it meets the targeted goal for the DFT. So this sound understanding of VLSI design flow, this I will be taking care. If you are not already aware, that's okay. I will explain it. But I would be expecting people to learn the digital design basics and basic electronics, the very minimum basics, like what is meant by a flop, what is meant by a logic gate, the operation sets of flops and the logic operations of gates, the true tables, expressions and all, and some basic component, digital design electronics and basic electronics. That should be sufficient. You don't need to really focus on developing some FSMs, state machines and all, not required. All the basic electronics and basic design, digital design is far good enough for us to start this course. I would expect some Verilog also. I hope like the basic sessions will be again revising all these two topics. So EDA tools I'll be explaining again. Wherever I'm writing explain, I'll be taking care as part of my course. So knowledge of C is a very common point you might have learned when you are studying your graduation, right? So it is not that difficult. But why do we insist to know the knowledge of C? Because the structure of C will be more familiar to this type of scripting languages what you see on the screen. There are some scripting languages like Perl, Shell and Tcl. I'll be explaining some basics on this, okay, not extensively, some basics which are far enough to handle these tools, because all these tools, the EDA tools, are built up of Tcl shell based. So to handle the tools, if you understand the basic syntax, that is far enough. Now what is meant by basics? Very simple basics. How do you set a variable? Set A is 10 and print it like print F or print statement and use it $A, which means you are going to print the statement of the value which is set into A. And some basic for loops, some while loops. Okay, this is far enough. There's some setting the variable, calling the variable, for loop and while loop is much more enough. If you're already aware of it, that's very good. If not, you can just try to focus on these basics. It doesn't take too much of time to self-learn these scripting languages. And as I told, I'll be also taking part of some basics. Okay. So this is the overall summary. So I would be expecting the digital design and Verilog from every one of you to understand as a basic concept and some basics of C. Like what is a function, what is meant by a function, how do you call a function, what is meant by a variable, how do you set a variable, how do you call a variable, how do you print a variable. So some sort of basics should be good enough. So remaining part we will take care. We can explain the skills which are required to start the DFT course. So now what is meant by VLSI design flow? It's also called as an ASIC flow. The full form of ASIC, ASIC is application specific integrated circuit. So we'll have some integrated, the chip is called as an integrated circuit. The circuit is integrated into a small device, what we call that is a chip. Since it is specific to an application, the chip will be working specific to an application. It's called application specific integrated circuit. In short of it, the pronunciation is ASIC. So what is this flow? So this flow includes the steps which are involved to integrate a chip. The steps which are involved to integrate or to create a chip in the software. So the first and foremost step in this flow chart which I have is design specification. So if someone wants to create a chip, if someone wants to really build up a chip, they first need to understand what is the application of the chip. So specification is nothing but what application is used for. So without that, there is no point of starting a project or start building up a chip, right? So first you need to understand. So there are a wide range of applications in the market. It can be your digital environment, which includes the different sectors like consumer goods or electronic devices like servers, and there can be something like, you know, some biomedical related instruments, or some defense or automobile industry we have, or it can be some artificial intelligence or some IoT, some different sectors of digital market we have. So everything requires a chip in a specific application. Very common applications are like Bluetooth, audio or video multimedia, or GPS, right? Or some networking chip, which is required for some routers or some laptops or smartphones. So any electronic gadget what you pick up, a processor or a chip need to be functioned on a board which gives the specification of the circuit. So there would be a separate team in most of the MNC companies where they would actually divide, they call themselves as architects. So the architects will actually decide what type of chip. So the sales team also will be involved here, because it depends on two different types of projects what we have. One is customer based project, one is company based project. So customer based is a project is something like they get an order from the customer asking to do a chip, build up a chip for a company. So imagine there is a company A who are manufacturers, and this company is the company who builds up the chips in terms of software and hardware. It's a company A. Now there is some customer here. The customer tells, okay, you build up me a chip, I'll give you some money, I'll pay you some money for the chip what you are going to build me. So this is called customer based projects. There are some other projects where the company itself builds their own design and they publish in the market. So they sell their product into the market. Some customers are interested by looking into the specification and they may actually buy it up. So either they get an order from customer, or the company will build their own design with the latest market technology and they sell it into the industry. So either way, the sales, the marketing people, the architects, everything will put a hand and try to understand what type of spec is required to build up the chip. So once that is decided, we have something called the design code team, which is nothing but the RTL team. They will start writing the code. A separate team or the same team, however it is based on the company size. So the design code team will start writing the code in different ways, like Verilog, HDL, or whatever system Verilog, if possible. However it is, they will try to develop a code in a Verilog. Most likely they will try to write in behavioral modeling. You have different modelings in Verilog structure, if you are aware, behavioral data flow modelings or structured mode flow modeling, gate level flow modeling, whatever it is. However, the designers will pick behavioral modeling. It's very more custom and easy way to implement and to start writing a code which can be replicated for multiple instances. So in a simple construct way, they can start writing code using behavioral. So once they have constructed it, there should be someone to validate and to verify. So one good example, very small example. It's a very, very small example. Imagine you are the design engineer. I have given you a specification asking that, can you build me a circuit for a adder? You know what is an adder circuit, right? Half adder, full adder, complete adder circuit, what you have. So you have built up a circuit writing a code for adder or a counter or accumulator. There are many components. Or imagine you're writing for a PLA, a small code, or you're writing for a code for some other components which I would like to, something like UART. Imagine there's a UART I asked you to develop and you started writing it, or there's some SERDES, actually there is some SERDES or something. Different components are there. So one of the code I asked you to write and you started building up. Now who is going to tell that the code what you have written is working as per the specification which I'm giving? So there'll be a new team here called verification. The verification teams will start validating the code what the design team has written. They will start they'll try to start validating it. They'll give some inputs and they'll observe some outputs and they'll try to see, yes, I have given an input, I have got an output, it is as per the specification we have. So it's a series of steps. It's a step-by-step process what we have. So once this verification team validates and tells that yes, the code is meeting the requirement of the spec, then it goes into the next phase called as synthesis. So synthesis is nothing but they're going to convert the behavioral Verilog code into the structural Verilog code. The gate level, I would say. Why do they need to convert it to gate level? Because in the Verilog behavioral code, you'll write something like always statements, right? This doesn't say the physical representation of a cell. This is just a logical operation. So in synthesis, we get the physical representation of a cell. a physical representation of a cell comes here for an AND gate. Okay, how does it looks like? A and D, and then you'll have something, a name here, and you'll have what is Y, what is A, what is B, how they are connected, something like this. So this is a physical representation of connections with some nets and all. I can write same AND gate here also, very simple, with assign statement of Y is equal to A into B. This is just a logical operation, not the physical representation of that logic. We need the physical representation of the cells, then only it helps us to go to the next streamline topic, which is physical design here. So the physical design is nothing but the layout where they do for the physical represented cells. So we need the code to be placed with the physical representation. And of course, after synthesis, we add our design circuits. The DFT teams comes into picture. They add the extra circuit. So DFT adds an extra circuit to the chip always. An extra logic or circuit to the chip. And this design is used only for testing. Yes, whatever you are hearing is right. You can add an extra specific circuit that can switch on and enable the test on the chip. It can perform the test and give you the result. We call an extra logic which can be implemented for the analysis of the test. Because they are very high complex designs, we have multi-millions of transistors, multi-millions of gates and flops. It is not that simple that you simply give an input value and tell me that, okay, what is observed output? It's too difficult. So we can place our extra circuits and using some tools, we can analyze the test mechanism and tell that, okay, we are going to test the chip and make sure it is a defect-free chip. So we are going to certify that it's a defect-free chip. So if the design is frozen up to here, all the design changes are done here. So up to here, the design is developed, integrated. Then it goes to the layout, which is physical design. They're going to do the physical layout. They'll take the chip and they'll place all the cells here. However, the cells are required. There can be some big modules, there can be small modules. So physically, they are going to do the layout of the chip, how it looks like for the fabrication. So once the fabrication, the layout is been done, we do something called a sign-off checks, where we perform the analysis, the timing analysis of the chip will be done. Some part of DFT analysis will be done. Some layout rules will be checked here. Some DRGs will be there. Schematic rules will be there. All this is a sign-off check. Sign-off is nothing but the final checklist you can consider before we give it to the manufacturing vendor. So the next step is the tape out. So tape out is nothing but it is not a team. It is just giving the database to the manufacturing vendor. So this is team 1, this is team 2, this is team 3, this is team 4, this is team 5, this is team 6. There can be multiple teams here, 7, 8, 9, but this is not a team. This is just a database handle in the entire flow. The final set of database we are giving it to the fabrication vendor. Okay, so this is the typical ASIC flow what we have in the entire chip integration or the chip designing or chip building the chip, what we do for in the VLSI. Now, what is meant by DFT? Now you understood the entire flow of the VLSI, right? So this tree is nothing but which I'm talking here, the sound understanding of VLSI design flow. The sound understanding is like you need to understand the flow, which team comes first, which team comes next. So it's a series of steps. Design team will do the work. They will give the work to verification team and synthesis team. Synthesis team do the work and then give to the DFT team. DFT team will do the work and give to physical design team. Physical design team will do the work and finally give the database to the manufacturer. So the work is dependent on one team to other team, the interlink between one team to the other team, or one domain, I would say, one domain to other domains. Okay. So what is meant by DFT in the entire ASIC flow? So DFT stands for design for test. So DFT is used to identify the manufacturing defects after fabrication or manufacturing, whatever it is. To identify the manufacturing defects on the chip after manufacturing, we need this DFT. So does that mean that we are going to use this DFT, or you are going to add this circuit after manufacturing? No. First we will add the design into the chip. With our design, the chip will be manufactured. After the chip is manufactured, we enable our DFT circuit in the chip and try to identify the defects. That is how the DFT plays a role in the entire ASIC flow. We add the chip, we give to the manufacturing. After the manufacturing is done, we actually enable our DFT circuit in the chip and start testing it and try to identify the defects and tell that whether there is a defect occurring in the chip or not. So we are not test engineers, by the way. I have that in the next slide. When I say like we are going to test the chip after manufacturing, we are not test engineers. We are designers. We are the designers who are going to add the extra circuit. So then who is going to test it? There'll be a separate team called as testing engineer. I'll come back to the previous slides also. We are not same from the test engineers. We are different from them. There'll be separate test engineers. So DFT engineers will add the circuit and go to the manufacturing. Then the testing engineers will come. They will start testing it. If it is failing, they do not know what is happening, why it is actually failing. So they will go back to the DFT engineers and ask for some debug analysis or for some help, asking for why it is failing. So the DFT engineer should be responsible to debug that. Why? Because we have added the extra circuit. So you are the master of the circuit. You should be able to debug and see why it is failing, whether there is a real defect or not. So let me go back to the previous slides. So the functional engineers, the design engineers, the actual functional engineers may say they have 20 years of experience and the chip is 100% correct for functionality, but still the chip is getting failed after manufacturing. So silicon is nothing but after manufacturing we get the chip. So you might be aware of the steps, the fabrication steps and all what we have. There'll be some VLSI fabrication steps where we take the silicon material, extract it from sand and using some crystal seed and all, and we make a silicon ingot which looks like a big rod kind of thing like this. We cut this ingot into some slices. We got one slice. So this slice will have n number of dies. Each die is nothing but one chip here. So this silicon is nothing but the die. What the wafer I'm talking about is this is a slice, or also called as a wafer. So this wafer is nothing but the silicon, what we call it. So the functional team says that we have given the logic very true, very perfectly. I don't know why it is failing on the chip, why it is failing after the fabrication. So the DFT engineers will, the reason for that is like there can be some manufacturing defects found during the testing. There can be some manufacturing defects which can occur. So what is a manufacturing defect? I'll come to that point. I have a separate slide. So during manufacturing, there can be some imperfection which can happen on the chip while fabricating that will lead unintended connection or unrequired, which will be causing the wrong output of the functionality of the chip. So that's called as a defect actually for us. So the DFT engineers can actually identify that by giving some test pattern analysis. So what is meant by testing?
We can give
What is meant by, what is meant by testing? It's a process of determining whether the device is good or not. So you give some input data here to the chip and you observe the output of the chip. You compare the response and tell whether it is expected output is coming to the chip or not. If
Either
not,
it is
it is
working or
failing.
not.
Sorry, there is some delay actually. Yeah.
Either
So
it is
whether the
working or not, sir.
whether it is working as per the requirement or not, that is more important. As per the requirement, it is working or not. The expected outputs, you'll have an output to be compared, and you give the data at the output side. You at the input side, you observe the data at the output side. You compare the output response whether it is matching with your current response or not. If not, it is failing. One good example is like you have an AND gate. I'm giving a value 1 and 1. I'm expecting a value 1, but I'm getting a value 0, which means I'm getting a false output. This is the output for my comparison. This is the output which I am getting. So obviously what is happening, there is some defect happening in this AND gate, which is resulting me some wrong output. So there can be a defect on this input, on this input, on this output. It can be a defect internal to the gate also. We do not know. Something is happening to this AND gate. So the behavior, the function behavior of this AND gate is not proper. I'm getting a wrong output. So that's called as a testing. So are we same from the testing engineers? No, we are going to add the circuit and give it to the fabrication. It goes to the testing team. There will be a test. There will be an equipment called as tester. So on this tester, you will be the testing engineer will place the chip. We'll have something called as load boards. We'll have something called as a load board where we place our chip here. There'll be some probes and all other things. There'll be a system actually like this. Some computer will be there. It will be sending the data to the tester, and the output response will be again can be observed in the system. So this is how the testing happens actually. So this process of applying the data onto the tester will be done by the testing engineers. Now the question comes, what data they are going to apply? The data has to be given by again the DFT engineers. So you have to insert the logic, you have to generate some data, and you have to give it to the testing engineers. They will start applying onto the tester and see whether it is pass or fail. They'll see whether it is pass or fail. If it is passing, then there is no defect you can consider like that. If it is failing, then there are many factors. There is a big checklist actually. There will be some 20-30 points of checklist what we need to do, and then conclude it whether the chip is defective or it is not. But who is going to do that? Some part of analysis testing engineer can do. What part of analysis? Whether this board is proper or not, whether this load board is proper or not, whether the probing is proper or not, whether the output is getting properly or not, whether the environment of this setup environment of this tester is proper or not. That's it. They can actually do the analysis up to that level. But if something is really proper or not inside the circuit, inside the chip, who is going to do that? The DFT engineer has to validate it or need to do it, because you are going to generate the data. This data is nothing but some vectors or some patterns, what we call. You're going to generate some patterns and vectors. The input stimuli, I would call. So you see an applied stimuli. This input stimuli is nothing but the pattern of data which you're going to apply on the chip. Since you're going to apply the logic, you're going to apply the data, you're going to implement the logic, you're going to generate the data what you have to give onto the tester. So the majority of the debug may rely on you why the chip is failing on the tester. We have to give the support to the testing team. So this is the whole process what happens. So we are not same as testing engineers, we are different from testing engineers. Okay. So what is the intention of DFT? To identify the manufacturing defects post manufacturing. How do you do it? We insert some extra circuit in the design. We enable the circuit once the chip is manufactured, and we give some set of patterns and vectors to the testing team, and we ask them to test it. They will apply on the tester. They will see whether it is passing or failing. If it is passing, it is defect free. If it is failing, they will try to do some part of analysis. If that is not working, they will come and take the support of DFT engineer to understand why it is really failing. We have to check it, we have to analyze it, and finally we have to justify and provide the report whether it is really failing, whether it is really a defect or not. So what is the course outline? I have a couple of points to discuss here. I will be discussing about the architecture of DFT. We'll be also explaining the scan, compression, insertion. This logic is responsible to test flip-flops and gates. There is another topic called OCC, on-chip clock controller. This explains how the clocking structure should be in the design for DFT. There is a controller logic. This is also will be inserted by the tool, but you need to understand what it is inserting. You may not be there to write the, you may not be required to write the code manually, but the tool can insert some FSMs also. So where the standard designs are available, you need to understand what it is inserting, where it is inserting, how it is making the connection, whether it is meeting your requirement or not. And you have something called MBIST, which to test the memories in specific. We can test the memories also using some digital circuits, because memories or operations are more frequent, like simple write and simple read. Right? You write a value and read the value of same value and try to understand whether it is passing or failing. So that part of testing can be accommodated in the digital DFT. And this is the JTAG is a protocol which is used to control the memories, to control this clock, of course sometimes to control this test also. So this is just an additional protocol to use the testing in an optimal way. So that is also an extra logic we are going to add. And B-scan is to test the inputs and outputs of the chip separately. Inputs and outputs of the chip separately, because what if there is a defect at the input and output of the chip? We are trying to target the flops, gates, memories, that is internal circuit of the chip. But what about the boundary? The B-scan stands for boundary scan. The external boundary of the chip, what if it is having a defect? So we can try to test that also in a separate test. So this ATPG stands for automatic test pattern generation. As I told, we have a separate tool which can actually generate the patterns on its own. The tools are a little costlier in the industry, but they are very highly automated process where it can generate the patterns which need to be given to the tester. So this pattern will be given to the tester by us. So before giving to the tester, we can do something called a simulation, which is nothing but we can validate them. The quality of the pattern can be validated using simulations. And this one is silicon validation, which means like the testing team will be doing this. So we can support, the testing engineer will actually do it. So what type of support we actually do it on, we provide it to the testing engineer. So I am trying to cover a wide range of topics here, which includes the insertion of the DFT, the pattern generation of DFT, the simulation validation of DFT, and support to the testing engineer. So maximum we are trying to keep the topics in the entire course of this DFT. Okay. So what are the different types of defects we may have on the chip? Some of the types of defects are, there are many types of defects. One thing I have listed here is common is point defects. What is point defect? There can be some scratches. There can be some bridges. Sorry. There can be some cracks. There can be some dark and missing vias. Vias is nothing but some node connections actually. Okay. So scratches means there can, while during manufacturing, what if metal? What is metal? Metal is nothing but a net connection. A wire connection is called as a metal. A metal is nothing but a wire connection. So poly is another metal, which another material which is used to used for the construct between the terminals of a MOSFET. You will have some drain, gate, source terminals, no? So the connectivity between drain to gate, gate to source, all this type of connectivities will be done using some layer called as some material called as poly. So if there is the property of the metals, the property of the material is getting disturbed during manufacturing because of n number of reasons. It can be a scratch, it can be a crack, it can be a bridging. Bridging means shorting between two wires, right? You can see some examples like this is a type of bridging, this is a type of bridges, or there is a corrosion. There is a corrosion happening because of metal property, okay, which results the breakage in the net, and there can be some wide open connectivity. Here this is shorts, but this is open, which means unconnected. So many reasons can be there which comes into picture during manufacturing. Since this is a physical, the fabrication is nothing but the physical activity of laying the chip layer by layer, or however it is, right? So there can be many reasons. There can be some overlaps also, which means there can be shorts, right? So however, whatever the reason it is, you can have a manufacturing defect. So what happens if a manufacturing defect is there? It will falsify the output of a MOSFET. It will falsify the output of a MOSFET. That will result a falsified output of a gate. That will result a falsified output of a circuit. That will result a falsified output to the chip. This is a module. This is a gate. This is a FET MOSFET. So one single disturbance in this connection will reflect this gate in a wrong output, will reflect this circuit in a wrong output, will reflect a wrong output in the chip. So it is very important that the defects shouldn't be occurring after or during manufacturing process. Okay, so the flow of DFT, I have 3 points: the insertions, generations, and validation, which I made it up. All these modules are like you're going to add the extra circuit, and you're going to generate the patterns and vectors which you need to give to the tester team. Before giving to the tester team, we validate them, we simulate them, qualifying the patterns whether they are proper or not, and give it to the testing team. So this is the overall flow of the DFT in simple terms, not very elaborated way, in a very simple terms. So the defects are categorized into some type of faults. We cannot actually open the chip and see where I have this breakage of material, or where I have the opens of the materials and all. That is not possible. We cannot open the chip and see whether it is broken, or it is unconnected, or it is porting, or it is tied, or it is shorted, or it is open. So rather, we classify all these defects into some terminology called as faults. So these are the important faults which we are going to target in the DFT course. What is the first and foremost defect categorized into fault? Stuck-at fault model. What is stuck-at fault model? A node or a net is stuck to either 0 or 1. So one good example: there is an AND gate, there is an OR gate, like this, and it is having some connection like this. Unfortunately, there is some connection where this input, what you see between the connection between the AND gate and OR gate, is also having a short connection to a VDD, which means this node is stuck to, this net is always stuck to a value 1. So whatever the data you are propagating from the input of the AND gate will not go to the AND, even if it goes to the AND gate output, cannot go to the OR gate input, because it is always stuck to a value 1. So we call this as stuck to 1 or stuck at 1. This is a defect. What is a manufacturing defect? Short between VDD to a connection, to a wire connection. If the short between if the same short connection happening with a wire to a ground connection, then we call that as a stuck at 0. And we call that as a stuck at 0. Now the same circuit I'm going to draw like this. Can you tell me, is this a defect or not? Can I call this as a stuck at 0 or not? I'm writing in short form SA0. The second input of the OR gate is again connected to ground connection. So can I call that as a stuck at 0? No, this is not stuck at 0 because it is intended. The design itself is intended. This is not a short connection. This is an exact expected connection where it is connected to ground. But here, there is a pre-connection existing from the buffer to the OR gate, and there is a short connection here to the ground. So this is a stuck at 0. The below one is not a stuck at 0. So an unintended connections happening in the manufacturing only, we can call that as a defect. The below one is not unintended. It's an intended connection. The OR gate input itself is connected to ground by the design team, by the designer who is designing the code. Then it is not a defect. It is expected. In the previous example, the buffer output is going to the OR gate, but unfortunately it got stuck to a ground connection. Then for sure it is a it is a defect, a short defect, and it is fault categorized into stuck at fault. So there are other types of delay faults also. This is related to delay fault, which is related to the delays of the gates and flops. So this is not a manufacturing defect. This is not a manufacturing defect because it is not happening to any material, right? This is more of often happening on the delays. So delay is something which comes in the timing analysis or timing related. The basically delay depends on two parameters: resistance and capacitance of the net or a load what we have for a gate. So based on that, these delay faults also can be added as an additional check for the DFT. So two types of delays we have. One is transition delay and one is path delay defect fault model. So path delay defect fault model is a subset of the transition delay, the gate delay. This is not a separate fault model. That is just a subset of transition delay fault. Then there can be another category of fault models which is related to the leakage current. So what is IDDQ? IDD is nothing but drain current. Q is quiescent, which means inactive state. Q stands for quiescent, which is inactive state. So when the inactive states is not in the sense not 0% inactive, not 100% inactive, almost close to 100% inactive, a minimal toggling activity in the chip, and then stabilized the toggling activity. There is no more toggling activity in the chip. Then you will have a leakage current which may occur in the chip that can cause the chip during the testing also. So for that you can actually consider something a fault model called as IDDQ fault model. Then we have something called as bridging fault model. Bridging fault model is nothing but you have an OR gate here, there is some inverter, and there is an NAND gate and going to some other buffer here. So two net connections are short in between. So this short connection is not related to, see earlier stuck at 0, stuck at 1 is a short connection to ground and to VDD. But this time the short connection is between two wires. Then we call that as a separate fault model called bridging fault model. If the net is stuck to ground, then it is stuck at 0. If the short connection is happening to VDD, then it is stuck at 1. But this time the short connection is happening. The short connection is happening between two nets actually, two existing net connections. So that's called as a bridging fault model. What we have. So there are many other fault models which are available, but I'm trying to list only few here in particular, which are very common and which are widely used. So simple example of an inverter. This is the inverter circuit. So what if there is a stuck at value of 0 here like this? So this, whatever the input of 0, 1 you give, the Y will always see a value of 0. So you cannot invert the data. So it is falsifying the output of an inverter. So likewise, it can be applied to gates also, not only for the inverters. So far what we're discussing, see here it is mentioned as stuck at 1 on the NAND gate input. and there is a stuck at 0 applied on the, stuck at 0 occurring on the output of a OR gate. We have different tools which are available in the industry for the DFT. These are the three key player role companies in the industry who are providing the tools to DFT: Synopsys, Cadence, and Mentor Graphics. So for every operation, see, this is it can be, they provide the tools. All these are tasks what need to perform, and all these are the different licenses what we call. One good example, if you would like to use the Microsoft Office, right, you need to have a license when you install it in the Windows, right? So Microsoft Office is a suite, actually. It's a suite of features. So what are the different components you have? You have Microsoft Office Word, you have presentations, you have Excels, you have some other visual effects, visual Word documents. There are many features in the Microsoft Office. So likewise, these are also the different tools, and they have different licenses to do each and every task of operation what we have in DFT. You may get a doubt, why did I include the synthesis? Synthesis is also co-relevant topic to DFT, where some part of DFT logic may be involved with DFT synthesis components. So I'm going to teach about some part of synthesis also, which is relevant and required for DFT. And we have some lab sessions also for that. So that's why I have listed synthesis also in this whole window of table. Okay. So how do we provide the lab sessions, or what are the topics we are going to follow? The memories insertion and testing we follow here to provide the lab sessions. The JTAG protocol scan insertion, I have two different flows to test the, this is just a flow only, not a methodology, just a flow. Two different flow, one single methodology. One single methodology, two different flows. Okay. The tool flows, actually. How do you want to strategize the flow? In two different ways we can do it. So we're going to see that in lab sessions. This EDT is also subtopic of scan. This is nothing but the compression, what you have seen in the earlier slides. And OCC insertion also we're going to do. The controller, clock controller logic also we're going to insert. And we are going to generate some patterns on the ATPG and MBIST also. MBIST and ATPG pattern generation, and we are going to validate them, qualify them before we give it to the tester. So that validation also will be taken part here. So these are the overall lab sessions which we have existing planned for the coming course. Okay. We'll be providing some VNC access or VPN access where you can start practicing on the weekends or working hours of the institute. So there'll be a assignments will be providing, and there'll be a separate mentor and tutor also who will be available to assist during the lab sessions. Explanation of lab, very important point, please understand, no need to take a note. Explanation of lab will be taken by me. Practice of lab, separate slots we have. Explanation of lab session will be taken by me in the theory classes. Practice of the lab is separate, where a mentor or tutor will be there for you, who has some industry experience of 2-3 years. They'll be available online, so you can start practicing while they are online. If you're stuck with some constraints or some inputs or some flow, some commands you are not able to understand, they'll be there to help. I'll be explaining each and everything. The complete explanation of lab will be taken by me, but practice of lab, some other tutors will be there who are junior level engineers in DFT. So we are going to follow the one single method, the standard tool here, which is mental graphics. So in this table, which if you see, we are going to use the mental graphics for MBIST insertion, which I'm trying to round off, scan insertion, compression insertion, ATPG pattern generation, and simulation. Only for the synthesis, we are going to take the Synopsys tool, which is very commonly used. So apart from that, we are going to use the entire DFT methodology with one single tool, which is widely used in the industry also, which is mental graphics tool. So a dedicated industry experienced mentor will be there, as I told, for the practicing of the lab sessions only, not explanation of lab sessions. Practicing the lab sessions, they'll be available online. Of course, if you have any questions which you are not getting clarified, we can still discuss them with in our regular classroom sessions also. In the regular classroom sessions also. So during the course, you can repeat the training. You can check with the admin ones. What is the new rules of set of regulations? I'm not aware regarding the backup classes, and then up to when you can repeat. There is something like you can repeat the classes if you have some thing you have missed and you would like to catch up in the next batch for that particular topic. Yes, you can do it. There'll be some backup classes also, like some recordings which can be provided for limited number of sessions. If you have missed, unfortunately you are not able to attend the course because of your some personal work and all, that support also we'll be able to give. But don't expect like every session will be able to give the recording. Some part of some limited, like 2, 3, 4, not more than that. That's what at least I know. So we'll be creating a separate WhatsApp group for one batch where we can discuss the queries and doubts and related to the timing sessions of the the course, or the weekend timing sessions for the sessions what we are going to conduct and all these things. So I'll be sharing the materials via Google Classroom. So I'll be requesting everyone to provide a Gmail account ID. So I'll be adding all those people into a classroom session where I'll be providing the materials to them, to each individual, and it doesn't have any validity. It's lifetime where you can access the materials once it is shared to you, and you'll be able to download it or keep it in for reference. But the medium of sharing the materials will be Google Classroom. So some documents related to the tools, commands and procedures, whatever it is possible, we will do it. If available and possible, whatever it is, we'll be able to do it. We cannot give extensively all the options and everything of the tool related options. No, so whatever the procedures we are reading the lab session, we can share it in the Google Classroom as much as possible to every user. So I'll be able to answer your questions and queries also during the weekends, in particular this slot 5 to 7. If you have any questions or queries, if you would like to speak to me, because I'll be also busy doing some other projects and work during the weekdays. So I specifically allocate this time to our organization and institute. So you can call me up. You no need to wait till the next weekend to attend the class and then ask me the questions and queries. Either you can actually ping me in the WhatsApp group, or you can actually call me up during this particular slot on the weekdays, apart from the weekends, because anyway weekends we are going to discuss, we're going to have some interaction sessions. So job opportunities, we have some tie up with different VLSI companies. So most of the students got placed. So hardly very few we have who are not yet entitled with some placement. 95% we see the placement nowadays because the market is very good. So most of the people are getting placed in the industry. We'll provide some mock interviews and previous interview questions for your preparation for the interviews also. Since it's a very small industry, the DFT plays a very key role in the entire ASIC or SOC flow. SOC stands for System on Chip. So we have multiple job openings even in the terms of VLSI, DFT also. So DFT is involved both in front end and back end. Why is it so? If you go to my initial flow, what I have shown you, so up to here we call it as a front end. This is called as front end, where you are going to add the design. The layout and other things are back end. That is how we call it. So DFT is something like you're adding some design in the front end and you're doing some analysis also here in the back end. So it is involved in both the flows, like in the back end and also in the front end. So it's mixed of both the categories. So it's not like VLSI or DFT is only in the front end. It is both in front end and back end together. Yeah. So that's all. I have a short demo to explain what is DFT, what is the role of DFT, and how it plays an important role in the entire flow of VLSI or in the entire flow of the ASIC flow, what measures it has, how it contributes to the chip integration and testing. So you are ready to start the course. All the very best. I hope to see every one of you in the next introduction of the course one we have. We are open to the questions. You can ask me any questions or you can type. I see already 2 questions coming. Video records of each day won't be available. No, that may not be available, Kumar. It's very difficult to provide. We are not encouraging in that fashion, but we have a different type of learning also. We have something called e-learning, where all the recordings will be provided, but the interaction with the trainer will not be there like a regular classroom session. It will be some limited. So regarding this, all the recordings, videos and all, you can actually get on to the admin and the Srinivas or whoever you're interacting with the management. So try to reach them. According to me, all the recordings will not be available to share. If you have missed anything somewhere like 2-3 sessions or 4 sessions in the entire duration, yes, it is possible to share. If you want all the recordings to be shared to you only for the learning purpose, we have a separate stream of thing called as e-learning course. That is a separate course where it is not a live session, it's just a recorded session of the course that you can check. Yeah, I'm not sure, Kumar, whether you have been in the initial slides when I started explaining. So I have given here also. So it will be a 16-week of course. You can see on the screen. It can extend up to 18 to 20 also based on the interaction what we have. Okay. Yeah, another question. Yes, as I told already, the difference and the gap between your graduation and looking for opportunities doesn't matter. If you are good enough to prove that you're able to handle both technical and practical sessions of the DFT, there are many people who are interested to take. But it all depends. You have to prove your performance to them in the interviews or however it is. So I have seen many people who are already are placed, even if they have some gap between their academics to their career start in the VLSI. Okay. Any other questions? If someone is applying for basic plus advanced DFT, when will the class start? Can you please check with management once? CA, there is, they will be providing the exact slot because I cannot actually divide and tell the time frame. They will be having some sessions and then some time slots allocated, the course modules and all. They will be tracking each and everything. So they'll be the right person, Omkar, to understand the basic as it wants. Okay. So ideally, I actually go for any regular standard explanations. Okay.
Yeah. So you mentioned that videos will be available, but I think Steve was told that at least for 1 week they will provide after the session. So
If you see, as I told, right, there are many regulations changed during COVID. Okay, because everyone is work from home and we are doing all online sessions. Maybe there are some leverages in the video sessions and all. So please check with the management only. They will be the right person to comment on that. Don't mark my words on that.
okay. Sure. And, when is the class starting? Like
your voice is not clear actually to me. Can you speak a little louder?
Sorry. So when is the class starting? Like tomorrow itself or on the next
This
weekend?
week we'll be starting with the basics, basic brush up of the digital design and other basics actually. Brush up classes what we call, ramp up sessions what we call. So it will be lasting somewhere like a month or and half, and then the actual DFT course will be started by me.
Okay. So like should we expect a class tomorrow or?
Sorry, should we expect
A class tomorrow or like next weekend?
DFT actual course will not be tomorrow. That's what I'm trying to tell. First, the initial ramp up sessions of digital design, basic electronics, Verilog and other things will come into picture, Linux and other things. Post the completion of the basic course only, the actual DFT course will be started.
Yeah, sorry. So I meant to ask like the ramp up, will it start tomorrow itself or
Yes,
like next
Monday
week?
is what I came to know. Yes.
No, but if I'm applying for a weekend course,
Then can you contact Manohar or Shilpa or Srinivas or whoever it is? Can you just try to follow up with them once? Exactly.
yeah, sure.
Because I'm not the owner
Yeah.
of the basic sessions, right? So I may not be the right person to answer that.
Okay. No. Okay.
Yeah, see, freshers are also, there are many openings. Experienced candidates, freshers, or whatever it is, we have wide range of openings in the industry. See, it doesn't matter whether you have experience or not. It all matters whether you're able to prove the interviewer that you're capable of handling the theory and practicals. That's what I would like to tell. Okay. So I would like trust your work rather than on the opening. It will automatically open the gates to your openings. Okay. So work from home, you're asking about the projects and the real-time opportunities that depends on company to company. Some companies are insisting to come to office daily nowadays because the COVID impact is not heavy. Some companies are still going for some hybrid models. Some companies are completely giving work from home. So I cannot completely provide an answer to you. It depends on the industry companies what we have, their policies. If you opt for the e-learning course, how do you clarify your doubts? I don't think so. There'll be a separate session. So far, I haven't done anything. Once in a while, I think I have done. When many people have requested one small clarification doubt session, I have taken. So that may be the drawback, I would say, if you go for only the e-learning sessions. But we can accommodate. We are not denying that we will not give any support. We can have very limited sessions for the doubt clarification. You may not be able to entitled to give n number of doubt clarification sessions. 1 or 2 are okay, that we can accommodate. That is not an issue. Okay. So the timings of the weekends, in the morning session of the weekend, somewhere like 10 to 1, I'll be taking the DFT theory class. In the afternoon, somewhere like 3 to 4 or 4:30 or 5, you will have some practical sessions of lab for the weekends. For weekdays, there is no theory from my end, at least. There can be some other trainers, junior trainers who can help with some doubts clarification and all. Practicals also the same way. What project experiments will be covered? Oh, okay, maybe I haven't explained that. So we have some different projects which we have developed here in terms of some levels, level 1, level 2, level 3 and all. So basically we cover one type of topic in level 1, then we boost up a little bit dose on the level 2, and then we increase the complexity in the level 3. So in such a way we cover all the wide range of topics like scan, MBIST, ATPG, OCC, simulations and all, in each and every levels of projects what we have. I have already given the list here, no? So all these will be covered in the lab sessions. Where is that slide? 1 minute. So these are the topics which we are going to cover in the labs. I have already told that also. I have written the statement also. I'm not sure you're following the slides. Please look into it once. I have clearly written the complete DFT flow will be practiced on industry standard tool mental graphics in the institute for the DFT. I have circled also here. I'm not sure you're following the session. So I have given the, where is the tools option here? 1 minute. Let me bring up that. See here, I have given the tools option. No, I circled like this also. I'm not sure whether you followed that part. So these are the tools. Mental graphics is a tool. I have given the list of the tools also here very clearly. Okay. Yeah. Any other questions? Anyone else? Please let me know. Are you clarified? Can you guys type responses in the chat window? Yes. Just simply type a keyword called S so that I can understand you will be able to you are able to follow the topics or follow the session. I see 3 responses so far out of 18 people, 17 people. 5, 8, 10, 11, 13. Okay, good. Okay, we have 2 more questions. Let me complete. Can you briefly explain the difference between DFT validation and pure DFT, and then talk about separate subunits? See, DFT validation is nothing but give me a minute. Where is this slide? This one. DFT validation is nothing but this part, the last part, what you are going to do. Pure DFT is nothing but you're going to insert the logic, generate the patterns, and then do the validation. If you do all the steps, it's pure DFT. Doing only validation is only DFT validation, what you're going to do. Of course, I did not add each and every micro detail. You'll have JTAG also here, all other components. It depends on company to company. So validation, if you're doing, you're stuck into only the DFT validation. Pure DFT is like you do all the insertions and then generations and then do the validation. That is the difference. That's it between the pure DFT and DFT validation. Probably I think you're not working in a DFT, Onkar. You're working as a DFX. You're a DFX engineer. I understand that. Inserting the tap links or validating the tap links at multiple hierarchies, right? For different instructions. I do know that. I also have experience in tap validation with all the flows what you might have worked. So you're more of DFX engineer. So pure DFT is like if you learn about the insertions and all, you'll be part of the DFT engineer. Will this course and lab sessions will be sufficient for us to get the job and work, or should we learn extra course? It's a very good question. I don't know whether you're questioning it or whether you're asking it. Okay, so there are many people who got opportunity by completing this course. So I would strongly at least tell it should be sufficient. So my explanation will be very in-depth, Pallavi. It's not like I would cover only the basics. See, I hope you might have understood by this time. If you are entirely present for the demo session, I go to the roots of the topics, whatever I touch. So that should be more enough for any individual. So this course will be helpful up to for a new fresher or a person who is starting their career in DFT, and also a person who is having up to 3 to 4 years of experience in DFT. Even they can also opt this course and they'll be able to understand. It will be helpful for them. Okay. Any new demo session is there? No, Sohel. Unfortunately, this is the only demo session we have planned for today. And tomorrow also there is no. You want to start RTL verification? Is it same in DFT? No, not exactly. That comes under verification domain, Sohel. I don't think so. You have attended this entire demo session. Verification is a separate team. What you see that doesn't come under DFT. Verification is different and DFT is different. So this course is only related to the DFT, design for test. Is my video lagging still, or it is synced with my presentation and my audio? Can you confirm now, Sandeep? Is it for everyone happening? Okay, good then. Yeah, so that's all. Thanks everyone. Thanks for your time. Any questions open, let me know. Open for answers, let me know. Or if not, we can close the session, the demo session for today. I hope to see every one of you in the next main DFT introduction session when I'm going to take. No more questions. Okay, good. Nice interacting with every one of you. Thanks for your time. Bye-bye.